Hello everyone, welcome to chapter 1.2 and we're going to look at how do I estimate an answer and how do I use place value to answer questions, okay? Apologies for the typo in the driving question there, it should be how do I estimate an answer, okay? So if you could please have a look at the warm-up activity, see what you can do, work your best through them, pause the video and then play when you're ready to go through the solutions. Okay, so let me just load my split screen and then we will see what the answers are to each of these questions and how you work through them successfully. Just have to give it a second for this to load for me. Okay, remember with significant figures, you start counting from the first non-zero number and you must make sure you don't use the value of the number. So I'll show you when this loads. Okay, so question 1 says write each number to I, 1 significant figure, and I part 2, 2 significant figures, okay? So we'll start with all the 1 significant figures. So question 1, part I, and let's do A. So we need to write 873,209 to 1 significant figure, okay? So remember I said you start counting from the first non-zero number. The first non-zero number is 8. You look at the number next to it, that's 5 or more, so I'm going to round 8 up to 9. And then I put zeros where the remaining digits are to hold the value of that number, okay? So I've rounded 873,209 to 900,000, okay? And that's 1 significant figure. Okay, SF means significant figure. Okay, next one, 2019. So we need to round 2019 to 1 significant figure. Again, you start counting from your first non-zero, that's my 2. Look at the number next to it. It's 4 or less, therefore it rounds down, it keeps 2 the same. So I've rounded 2019 to 2000. That's to 1 significant figure. And remember my zeros need to go in the other places to hold the value of that number, okay? We're estimating, we're rounding it. So 2019 is roughly 2000. Okay, and then part C, we've got 0.007059. Okay, we want to round it to 1 significant figure. As I said, you start counting from the first non-zero number. 7 is my first non-zero, so that's where I count from. Okay, so that's 1. That's 1 significant figure. Look at the number next to it. It's 4 or less, therefore it's going to keep the 7 the same. And that's my answer there is going to be 0.007. You don't put the noughts in after it because it holds no value thereafter. Okay, but the ones in front are very important. And again, that's 1 significant figure. Okay, now part 2, we need to do 2 significant figures. So we're looking at part A, we've got 873,209. We want to round that to 2 significant figures. You start counting from your first non-zero, so that's 1, 2. Look at the number next to it, it's 3, so that's 4 or less, therefore it's going to keep my 7 the same, and therefore it's 870,000 to 2 significant figures. Okay? Part B, we've got 2019. Start counting from your first non-zero, that's my 2, so 1, 2. Look at the number next to it, it's 4 or less, therefore it's going to round down and keep the same, so it's going to be 2000 again. And that's the 2 significant figures. And part C, we've got the 0.007059. We want to round to 2 significant figures. Start counting from the first non-zero. 7 is my first non-zero, so I do 1, 2. Look at the number next to it, it's 5 or more, therefore it's going to round my 0 up to 1. And my answer will be 0.0071 to 2 significant figures. Okay? Well done if you got those. Question 2 says work out, and then part A, we've got 9 times 4 plus 7. Okay, so this is all about your order of operations. We've got brackets here, so we must do our brackets first. 4 plus 7 is 11, so we're actually doing 9 times 11, which is 99. B, we have got 5 plus 3 times 8. Again, you need to think about your order of operations, so your BIDMAS, order of operations. What comes first? Well, multiplication comes before addition. So I need to do 3 times 8 first. 3 times 8 is 24. So I'm actually doing 5 plus 24, which is 29. Part C, we've got 7 multiplied by 5, subtract 4, multiplied by 2. Okay. Multiplication has higher priority than subtraction, so we need to do our 2 multiplications first. 7 times 5 is 35. 4 times 2 is 8, so I'm actually doing 35 subtract 8. Okay, and that will be 27. Part D, I've got 30, subtract 5 times 8. Multiplication has higher priority than subtraction, so I must do my multiplication first. So I'm actually doing 30 subtract 40, which is equal to negative 10. Part E, it's just 72 subtract 9. So that would be 63. Okay, and part F, we've got the square root of 29 minus 4. 29 minus 4 is 25, so it's just the square root of 25, which is 5. Okay? Then, question 3 has asked you to find the mean of 3, 6, 7, 9, 15, and 20. Okay, so this is question 3. So you want to work out the mean. So to work out the mean, you need to add them all together and divide them by the number that there are. So there's 3 plus 6 plus 7 plus 9 plus 15 plus 20. So we need to work that out first. 3 plus 6 is 9, plus 7 is 16, plus 9, so what was on there? So 16 plus 9 is 25, plus 15 is 40, plus 20 is 60. And we have got 1, 2, 3, 4, 5, 6. So I then need to do 60 divided by 6, which gives me 10. So my mean is 10. Okay? So let's move on. So I'm going to work through this question with you as my model question. We're looking at estimating calculations, okay? Getting approximate values for calculations using the facts that they've been given us, okay? So let me just get the screen up again. So all you're doing now is you're looking at the relationship between the fact they've given you and the question they've asked you, okay? So they've told us that 3.7 multiplied by 9.86 is equal to 36.482. Okay, that's what they've told us. And for part A, they want to know the answer to 37 multiplied by 9.86. Okay, so what I'm going to do is I'm going to say, well, what has changed here? 9.86 has stayed the same, but 3.7 has become 37. So 3.7 has become 10 times bigger. Therefore, my answer is going to become 10 times bigger. So I'd multiply my 36.482 by 10, and that would give me 364.82. Okay, and then it says, check your answer using an approximation calculation, okay? So roughly, if we round each one to one significant figure, 37 would be 40 and 9.86 would be 10. So 40 multiplied by 10 is 400. So we'd expect it to be around 400, but we've rounded them both up, so we know it's going to be less, and therefore that looks like a good and sensible answer. Okay, part B. We've got 3.7 multiplied by 0.0986. Okay, and I want to know the answer. So what I'm going to do there is I am going to compare to my original fact that they've given us. So the 3.7 has stayed the same. The 9.86 has become 100 times smaller. Okay, because if you divided 9.86 by 100, you'd get 0.0986. Okay, as this has become 100 times smaller, my answer is going to have to become 100 times smaller. So I need to divide my 36.482 by 100. So remember, that would move my decimal 2 places to the left and leave me with 0.36482. Okay, let's use the approximation now again. So we're going to round each one to one significant figure. That would be 4 multiplied by, first non-zero is 9. The 8 would round the 9 up to 10, so top by 0.1. Okay? So 4 times 0.1 would be roughly 0.4. As we've rounded them both up, we know that our actual answer is going to be a little bit less than that, so that looks about right. Okay, that looks like a good and sensible answer. Part C. 0.0037 multiplied by 98.6. Okay? I need to look at my relationship between each. They've both changed now, but I just need to see by how much. So to get from 3.7 to 0.0037, we would divide 3.7 by 1,000. So 1, 2, 3, yep, it would be divided by 1,000, okay? So this is 1,000 times smaller. I'm just going to write it underneath so I don't forget. So that's become 1,000 times smaller. And this one has become 10 times bigger, right? Because to get from 9.86 to 98.6, I need to times by 10. So this is 10 times bigger. So I've times by 10 there. So what's going to happen to my answer? Well, the net effect is actually my answer is going to be 100 times smaller, okay? Because I would first make it 1,000 times smaller, my answer, then I'd make it 10 times bigger. And the net effect of that is just making it 100 times smaller. So if I divide 36.482 by 100, I move 2 places to the left, I get my 0.36482. Okay? Let's check that by rounding to our significant figures to get approximate calculations. First non-zero is my 3. My 7 is higher than 5, so it's going to round my 3 up to 4. So it's 0.004 multiplied by my 8 will round my 9 up to 10, so multiplied by 100. Okay? So 0.004 multiplied by 100. When I multiply decimal by 100, I move my decimal 2 places to the right, to the right. So 1, 2, so my answer should be approximately 0.4, which it is. It's almost 0.4, okay? It's less than 0.4 because I've rounded each of these up, but it's approximately 0.4. Part D, let me just move this up a little bit. We have 36.482 divided by 9.86. Now, they've changed the order here a little bit, but actually the numbers haven't changed. So we've got 36.482, our original fact was 36.482, divided by 9.86, and so we know our answer is going to be our 3.7. Okay, so our answer there is 3.7. We can use approximation now to check this and find an approximate answer to the solution. If I round this to one significant figure, it's going to be 40 divided by 10. So approximately my answer should be 4, and it is almost 4. Okay? Part E. I can now use that one as my fact, by the way, because the rest of division. Part E, we've got 3,648.2 divided by 98.6. Okay? So what's changed? Well, 3,648.2 is 100 times bigger than my 36.482. So it's 100 times bigger. That's been multiplied by 100. And my 98.6 is 10 times bigger. Okay? Now, this is the thing with division. If this is 10 times bigger, 10 times less will fit into this number, okay, than if it was 9.86. Because more 9.86s would fit into 3,648.2 than 98.6s would, okay? So when I consider my answer, I'm first going to make it 100 times bigger, and I'm then going to make it 10 times smaller, okay? So 100 times bigger would make it 370. 10 times smaller would make it 37. So it's going to be about, oh, sorry, I've used that one, haven't I, instead of the, what have I done there? I've done that wrong, haven't I, because, oh no, I haven't, that's correct. Sorry, it just threw me looking at that one. No, 37 is correct, so yes, 37. Okay, so let's check, find an approximate solution for this by rounding to significant figures. First non-zero is there, the 6 rounds the 3 up to 4, so it's roughly 4,000 divided by 100. Okay? 4,000 divided by 100 would be 40, so my answer should be roughly 40, and it is. 37 is almost 40. Okay? And that's how I did that one. Okay, and then part F, we're doing 364.82 divided by 370. Okay, so I'm going to use the division fact that I've got up here, but I need to rearrange it because now I'm dividing by 370 instead of the 9.86. So the fact that I need to remember that I'm going to compare it to is 36.482 divided by 3.7 is equal to 9.86. Okay, so what did I do to get from 36.482 to 364.82? Well, it's 10 times bigger. So that's been multiplied by 10. So at the moment, I'm making my answer 10 times bigger. Okay, so that at the moment would be 10 times bigger, which would be 98.6. Then I look at the 3.7. How have I got from 3.7 to 370? Well, I've times by 100. Okay, I've times by 100 to get to 370. Remember, as this is bigger, less of them are going to fit in. So I'm actually going to make this one 100 times smaller to divide by 100. The net effect of timesing by 10 and dividing by 100 is just going to be dividing by 10. So 9.86 divided by 10 would be 0.986. Okay, let's check that using rounding them to significant figures and finding an approximate solution. 364.82 rounded to one significant figure would be 400. Divided by 370 rounded to one significant figure would also be 400. 400 divided by 400 is 1. And my answer is approximately 1. Okay, 0.986 is just less than 1. So my answer is correct. Okay? Now there's a chance for you to have a go at something similar. So if you could have a go, please, at these 3 questions. I'm just going to talk you through them quickly. And then you can pause the video and then play when you're ready for your solution. So you've been given a fact there, like we were given in the last example. And your fact is 54.8 times by 7.29 is 399.492. Part A wants you to write 3 more calculations that will have the same answer. So think about how you'll do that. Part B says write down a division that has the answer of 54.8. So think about how you'd rearrange your fact. Part C, write down a division that has an answer of 0.729. So think about what you'd have to change. Be careful, remember it's a division. And then part D says Charlie says that 54.8 times 72.9 is equal to 3,989.44. Explain why he must be wrong. Question 7 says write down the value of root 4 and root 9. So you should know those. Part B says estimate the value of root 5, root 6, root 7 and root 8. Round each estimate to one decimal place. Okay, so use the two facts that you know for root 4 and root 9 and then use that to help you find an estimate for the root 5, 6 and 7. Then part 2, use your calculator to check the answers to part B. Question 8 says estimate the value to the nearest tenth. Okay, so you need to be finding what's the nearest square root that you can find to those numbers that you've been given, and then use this to help you find a good estimate for those answers. Okay, so pause the video and play when you're ready to go through the solution, please. Okay, answer on the screen. I'm going to get the split screen up now so that I can go through some of the solutions with you. Okay, so the fact that we were given for question 6 was 54.8 multiplied by 7.29 is equal to 399.492. Okay, and it says part A writes down 3 more calculations that have the same answer. So 3 more calculations that will give me the same answer as 399.492. So what would you have to do to get the same answer there? Okay, so for example, one thing I could do is I could make my 54.8 548, so I make that 10 times bigger and therefore make the 7.29 10 times smaller, so it has the same net effect on my answer. So I could do 548 multiplied by 0.729, and that would give me 399.492. Maybe I'm going to make this 100 times bigger, make it 5,480, therefore make my 7.29 100 times smaller, make it 0.0729, and again I'd get the same answer. One more, I'm going to make this one 10 times smaller this time, so therefore make this 7.29 10 times bigger. So it'd be 5.48 multiplied by 72.9, and that would also give me 399.492. Okay? Those 3 options. There's lots of other ways you could have had it. Check yours on the calculator if I haven't put it there. Okay, so this was 6A. 6B says write down a division that has the answer of 54.8. Okay, so all you had to do is rearrange the original fact that they'd given you. So it should be 399.492 divided by 7.29, and that would give you 54.8. Okay, you could have also used any of your facts here and rearranged those. Just please check whatever answer you put, please check it on your calculator if I haven't gone through them there. Okay? Part C. So part C has said, write down a division that has an answer of 0.729. Okay, so that's made this 10 times smaller. So it wants an answer of 0.729. What I'm going to do first is I'm going to rewrite my original fact with putting 7.29 in the answer, and then I can look at what I have to do to make that adjustment to get 0.729. So 399.492 divided by 54.8 is going to give me 7.29. So I now need to see, what do I need to do now to get 0.729? Okay, if I make my divisor here 10 times bigger, I'm going to get an answer that's 10 times smaller, okay, because less of them are going to fit into the 399.492. So in order to get that answer, 399.492 can stay the same. And I'm going to divide that now by 548 because I've made that 10 times bigger, which is going to make my answer 10 times smaller. Okay, again, whatever one you picked, please check your answer on the calculator if I haven't gone through it. Part D. Charlie says that 54.8 multiplied by 72.9 is equal to 3,989.44. Explain why Charlie must be wrong. Okay, so let's have a look at the original fact that we were given. 54.8, that one stayed the same. 7.29, that's become 10 times bigger to 72.9. So we'd basically expect our answer to be 10 times bigger. But for some reason, Charlie's digits have totally changed. Okay, the 39 is the same, but then they've changed after that. So he's wrong because it must use the digits that are used here. Okay, so that's what you should say. So he is wrong as the digits 399492 should be in his answer, and then you can put his answer should be and we said 10 times bigger, so 3,994.92 should be his answer. Okay? Okay then, so let's go on to question 7. 7a wants you to write down the value of the square root of 4, which you should all know is 2, and the square root of 9, which you should all know is 3. Okay? That was the first thing you had to do. Then, part B says estimate the value of root 5, root 6, root 7, and root 8. Round each estimate to one decimal place. Okay, and they've said to you to use a number line to help. So, if I draw out my number line, I've got root 4 here, which I know is 2. And then I've got root 9 at the end, which I know is 3. So that means all of the roots in between, so for the root 5, let's see, root 5. Let's try that. So root 5, root 6, root 7, and root 8, it's just slightly off there. We know they're going to be between, their answers are going to be between 2 and 3. Okay, and they just want an answer that is rounded to one decimal place. Okay? So you had to think of an answer for each of these, just roughly, and I'm just going to leave it to whatever you've kind of put down there, okay? I'd say I would have gone for probably roughly 2.5 for root 6. So the square root of 6, I would have gone for about 2.5 because, oh, I didn't need the root there, because it's in between the 4 and 7. It's probably more towards 2.4 than it is 2.5 because it's not exactly halfway between. So maybe 2.4 might have been a more sensible answer there actually. So 2.4 is what I'm going to go for. Okay, and then the other answers you work out from that. So again, like I said, you're estimating it. So as long as it's a sensible answer, it's kind of up to you. I'm going to go for about maybe 2.2 for root 5. Root 7 now I know is going to be more than 2.4. So maybe 2.6 we could go for, something like that. And then root 8 is going to be between root 7 and root 9. So it's going to be between 2.6 and 3, isn't it? So maybe 2.8, because that's just in between, okay? And they're just my estimates to one decimal place. Then part C has said, use calculator to check your answers. So for part C, you had to put each of those into your calculator and check your answer. Sorry, I didn't realise you couldn't see that there. Okay, and then check your answers. My estimates were pretty much correct in one decimal place. There wouldn't be a one decimal place answer though. So roughly my answers were okay. If you kind of did one decimal place either side, it's fine. Okay, we were just estimating, trying to use what we knew to help us get some kind of solution there. Okay, and then question 8. We need to estimate the value to the nearest tenth of root 47. Okay, so root 47. You needed to think about which one you knew. What is the closest? The closest one is going to be root 49. Root 49, square root of 49 is 7. So you're going to use that. You know it's going to be less than 7. You know it's going to be 6 point something in between. So what I would then think of is like what we did before, is what is the square number before that? So we know root 49 is 7, and we know root 36 is 6. Okay, so root 47, which is what we're looking for, is very close to root 49. Okay, much closer than it is to the 6. It's going to be a high in the 6s, isn't it? So you needed to just give a sensible estimate for root 47. I would say it would be very close to 6.8, 6.9. Let's go for 6.8 because we've got a 48 in between. So I'd go roughly to 6.8. Okay? And you use the squiggly equal sign, which means approximately equal to. So I've gone for 6.8. I think 6.8, 6.9 would have been the sensible answers there. I'm not going to go through the rest because they are all approximations, okay? And the answers are at the bottom. That's once they've been checked on the calculator afterwards. They've given them to one decimal place. As long as you're like one decimal place either side of that, I'm reasonably happy with your estimation, okay? Oh, that wasn't what I was supposed to do. Okay, and that's the end of this session. So well done. I know some of it's a bit strange, especially with those finding the approximate answers for the roots, but it's really good to consider and think about what you know so that you can come up with sensible solutions, and that's so you can be checking your own answers for things as well. So well done. Thank you very much.